the focus of this lesson is graphs. So how do we get them? What do we do with them? How do we play with them? What's the point? Okay, so graphs are something that are in your book, it's in the syllabus, and it is something important to understand. But it's also something that's rather nice because it works with straight lines, with curved lines, with quadratic, with cubics, with quartics, with reciprocal graphs. They all work the same way. So what we're going to do today is we're going to have an overview of those curvy graphs because generally they do a different set of problems to the straight line graphs. So overview of curvy graphs, and then we're going to actually work through a past paper question so you can see how the things actually work in a question. So when it comes to curvy graphs, we've got three types that we're looking at in IG Maths. We have our quadratics, we have our cubic, and we have our reciprocal. Ooh. Okay. So what do each of these look like? It's a good idea to have an idea of what you're looking at whenever you look at an equation. So a quadratic, you could have ax squared plus bx plus c. It would be a y equals, wouldn't it? Because we're drawing these as graphs. So y equals ax squared plus bx plus c. Or you could have y equals minus ax squared plus bx plus c. And it's very important, that difference between the a and the minus a, because it actually changes what our graph looks like. So here we have positive a, and positive people are happy people. So a happy quadratic is a smiley face. Negative a, well, negative people tend to be sad people. So we have a sad face for an unhappy quadratic. And that is then the general shape for our quadratic. So it might be squished in, it might be straightened out, it might be more curvy flat and more sort of pointy, it might be different places on our axes, but the idea is that when it's a quadratic, we're going to have a smiley face or a sad face. Fancy name for it is a parabola. Quadratics are quite important in our life, which is why we actually have quite a lot of things that we do with them special from other graphs and functions and equations. Okay, when it comes to cubic, we have the same thing. We could have y equals plus x cubed, or we could have y equals minus x cubed. Now here we would have a different shape. This would give us a shape that looks like this, and this would give us a shape going like this. But now remember, of course, you shouldn't just often have x cubed on its own. You would have x cubed, x squared, and x, and a constant term, all within a cubic equation. And that's then going to have all sorts of different impacts on how it looks. Same thing with a reciprocal. Our options for a reciprocal would be y equals a over x, or in this case slightly different, y equals a over x squared. And here we have to draw in some axes because we have some asymptotes going on. So a over x looks like this. It can't touch any of those axes. So we have one curve that's stuck alone up in the top right, and the other half of the curve is stuck alone in the bottom left. When it's y equals a over x squared, well, x squared, of course, makes everything positive. So here, our curve sits all where y is positive. Okay, so again, it splits. So if we go back again, we've got the quadratics, smiley faces or sad faces. We have our cubics, wobbles, okay, an up wobble or a down wobble. And we have our reciprocals, two pieces, either up and down or both up, depending on what we're looking at in terms of x or x squared. So what we call these little lines here, where we don't cross, This is an asymptote. So an asymptote is a line. It doesn't have to be an axis. In some graphs, you'll see it's a different line entirely. It's a line where the curve gets closer and closer and closer, but it never actually touches. So remember, that's quite different to a tangent, because a tangent touches a curve, only at one point, but it touches. An asymptote, it can never touch. And if you think about it, it makes sense. Okay? If we said in this equation that x equals 0, so our y-axis, we'd have a divided by 0. We can't do that. Our calculator is going to say error. Because how do you divide a by 0 people? I mean, if you've got 10 suites and there's no people, there's nobody to have those 10 suites. So we can't divide by 0. Okay, so we can never hit that y-axis. The y-axis is an asymptote. If we look at our x-axis, okay, let's say y equals 0. Then we would have y equals 0. Then we would say, okay, what's the value of x? We'd say x times 0. Well, 0 equals a. That makes no sense at all. Okay? So we can't cross that x-axis either. Okay, and then the same thing here when it comes to the y equals a over x squared. We cannot touch those axes. We cannot have x equals 0 or y equals 0. So those axes become asymptotes. Okay, so minus a over x is going to do a very similar thing, okay, because he's going to look, okay, what if my values then, let's make them all minus. So all that's going to happen is he's going to flip up. So the same way in the quadratic and the cubic, you see how they flip up. So if we do minus a over x or minus a over x squared, it's going to flip as well. So they're not generally covered, but just because we have interested people, if we have minus a over x. So instead of being an output here of 3, it would be an output of minus 3. So this piece will go down, and this piece, instead of being an output of minus 3, would be an output of 3. So it will come up. So then minus a over x squared would do the same exact thing. Instead of being positive outputs, now we would have, everything would be negative outputs. So he's just going to flip. We're effectively reflecting in the x-axis. Geometry and algebra and curves and graphs and all of this all ties together so nicely. And that's why I have to admit I'm a little bit biased towards AS Maths, because when you get into AS Maths, then you get to play with this a little bit more. Okay, for the moment, never fear. We are just getting an idea of what these curves look like, but what we're going to then do with them is actually plot them. So we would be given an equation, and we would say, have to then draw the graph. So what you want to think about then is when it comes to drawing graphs. We're going to use graph paper. My dear, darling, wonderful students. Graph paper is that one that has a 2 millimeter grid. So you've got a fat lines, and then you've got a whole lot of lines, and then a whole lot of lines, and then you've got usually a medium line actually in the middle as well, but it's not as fat as the fat lines. Okay, that's your graph paper. So it's a 2 millimeter graph paper. So the big one is 2 centimeters. The medium one is 1 centimeters, and each little block is 2 millimeters by 2 millimeters. And you need to get yourself a graph paper pad, because you need to be drawing these graphs when you're doing your exercises on graph paper. You are so much more accurate when you do them, and at the end of the day in your exam, you're going to have 2 millimeter grid. So it is really important that you get that practice on it. So you don't have to bring that own graph paper into the exam. The exam papers themselves have the graph paper built in. We're going to see it just now when we do the example. Okay, but when you are drawing graphs, when you're doing your exercises, when you are practicing, draw them on graph paper. Next one. What you're going to do is you're going to create a table of values. So you would have y equals x squared minus 2x plus 3. And then you would say, okay, there's my table with a ruler, darlings. You would have x and you would have y. And you say, I'm going to draw minus 2, minus 1, 0, 1, 2, or whatever the question tells you. You know, there's going to be guidance on all of these sorts of things. So then you would plug in your x value, calculate all your y values. And you see what you get there is a coordinate. When x equals minus 2, then y equals whatever it equals. I haven't calculated it. Okay, but the idea is here that we're going to create this table of values for whatever curve. It doesn't matter what the curve is because we can look at our equation and get our values of x. Okay. Now you've got your table of values, you're going to plot your graph. So you're going to go onto your graph paper and you're going to plot every point with an X. See that? Okay, that is a whole lot more accurate than a blob. So let's just highlight this. On our beautiful 2-meter grid, you would have an X. Sometimes they'll be in the middle of a block, okay? Still an X. If you go and you scribble blobbies, it's like, okay, well, where's the point? Is it here or here or here or somewhere else? So no blobs. Use your X's to plot points. Not algebraic X's, because they're too curvy. Nice little plain old English X. Okay, so fourth one. Now that you've got all your points, you're going to join all those points very smoothly with a curve. Okay, and keep an eye out for discontinuities. So a discontinuity is where the graph breaks. So if we go back quickly here, this is a discontinuity. So this is one long function, but it has a discontinuity, a break at the y-axis. So again, they're going to give you all sorts of weird, wonderful curves. Doesn't matter. Keep an eye out for those discontinuities. You'll see just now. Okay, so we have our points. And then we join them smoothly with a curve. Something that can help, sometimes it helps to rotate your paper, okay? Always try and draw the curve. Now this is wonderful because you can't see my hand. So if my hand is here, draw this curve here, okay? If your curve is going the other way around like this, rotate so that your hand is on the inside of the curve. You'll find that it's probably a lot easier physically to draw a curve from the inside than from the outside. Okay, so here my hand was here my hand was here. So it's a little bit difficult to do on screen. Okay, but you're always trying to draw from the inside of the curve is a more natural movement. Okay, so we have a question come through also about how you draw your axes. Okay, axes are non-negotiable, of course. We need an x-axis and we need a y-axis for every graph. Often in your question paper, in your exam, you'll be given them just in case. And for when you're doing exercises, y-axis always vertical, and it has its little thingies to indicate where the values are. X-axis always horizontal, also with things to indicate the numbers. We put an arrow on one end of our axes usually, because that then indicates that it's going on. And it makes a difference between the arrow of the axes and then the line. So there is no confusion if we have a horizontal line or a vertical line. Which one's my line, which one's my axis? Because we always have those arrows. So an arrow on the top of the y-axis and an arrow on the right of the x-axis is what we generally do. Are we happy? Can we have a look at a past paper question? Okay, so we have happy people. One query, why not arrow on the top and bottom? It's just a clarity thing. There's nothing wrong with putting an arrow on the top and the bottom because in theory it extends in both directions. We just try and keep things a little bit simplistic, and generally then our axes get an arrow in one direction. So we're trying to keep sort of a minimal guide as to what it is we're showing, so that there's not too much that the person who's looking at it, then their eyes get confused by what they're seeing. So let us now head to our past paper and see what does this all look like in an actual question. So this is from March 2016, it's paper 42. You will often find your graphs in paper 42, but do not decide that you're not going to learn them for your paper 2, because they can come up in paper 2 as well. So we have question 7, the table shows some values of y equals x over 1 plus x squared when x doesn't equal 0. So, few things. X plus 1 over x squared, we did not look at that. Okay, but what did I say? I said that whatever methods you use for all of those graphs is the same. We have the same approach. So even if our graph gets more funky, we have the same approach. Note that they say x doesn't equal 0. So this, therefore, is a discontinuity. And what is most wonderful, see here in the table of values, they put a gray block. That is showing you this graph does not connect. We have one piece from -2 to -0.5, and we have a second piece from 0.5 to 3 in this case. They ask us to complete the table of values, so that's what we said. The first thing we need to do is get that table of values. How are we going to do that? We're going to take each value and we're going to plug it in. So, to get this -0.5, we would need y equals -0.5 plus 1 over -0.5 squared. Okay, and remember we do all our substitutions with brackets, because then we can protect that negative sign so that it disappears when it needs to and it appears when it needs to. So the answer to this is 3.5. So when x equals -0.5, then y equals 3.5. We can do the same thing. We can even go in our calculator and we can just edit the value that we put in if we set it up nicely and change that to a 1.5. So 1.5 plus 1 over 1.5 squared. That gives us, well, to 2 decimal places, 1.94. So what you want to do is always keep an eye on the accuracy of the other values in the table and round your numbers to the same. Okay, so then if we do the same thing, if we take out our 1.5 and replace it with our last value of 3, then our answer to 2 decimal places is 3.11. So now we've got all the x values and all the y values. Next is to plot each point with an x. And here you go with your graph paper. So it looks a little bit ugly and a little bit like your eyes are going to go squonk, especially when we look at it on a screen, but it's not so bad when you look at it on paper. And it does actually print with that heavy lines on the numbers. Okay, they even put scale values in for you. So what we've got to do is we've just got to go ahead and plot it. So given space constraints, I've got the numbers here beside me. Now first one is x equals -2 when y equals -1.75. So there we have -1. Okay, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blockies to 1. So it's 1.1, 1.2, 1.3. Always check your scale before you use it, and it's the same. 0.1, 0.2, 0.3 up to 1. So there's our 1, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. Now 0.75 would be there. Now you could also have gone backwards from 2. 2 minus 2 minus 1.9 minus 1.8 minus 1.75. It's about finding where you're comfortable. So our next one, at -1.5, so halfway between -1 and -2, -1.06. Now that is not -1.1, it's halfway between. And you would expect to be a lot more accurate on your paper and pencil than me with my digital pad and PDF. Okay, next one. -1 is at 0. Next one, minus 0.75 is at 1.03. So there is our -1. So 9, 0.8, so 0.75, there's 1, so 1.03 is right in the middle of that block. So you see also now, the points are not always on the line. So they're getting a good test, and you have to be accurate to within a millimeter. Okay, it's got to be in the middle of the square if it belongs in the middle of the square. Then our last one, minus 0.5, was our calculated value of 3.5. So 3, 0.1, 0.2, 0.3, 0.4, 0.5, 0.1, 0.2, 0.3, 0.4, 0.5. So there is our minus 0.5 and 3.5. We had that discontinuity gap. Remember our nice gray bar here. So our next one is going to be 0.5 and 4.5. So up to 4.5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's the 0.5. Okay, 0.75 and 2.53. 9, 8. Ooh, this is okay. Let's go up here. So 2.53. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. But I want 7, 5 and 5, 3. So I'm in the middle. That's a bit of a big X. Okay, 1 is at 2. Thank you very much, examiner. You've given us sensible values. 1.5 is at 1.94. So 1.5. I'm going to need to get glasses after this lesson, ladies and gentlemen. 1.94. 2 is at 2.25. So there's 2, 2.1, 2.2 and a bit over. And 3 takes us to 3.11. So 3.1 just above. Now we must remember when we join our curves that we have to leave these ones unconnected. They've got a gray block between them. X cannot equal 0. We have a discontinuity. The y-axis is an asymptote for this curve. So I would really dearly love to turn my paper upside down and draw my curves from the inside, but unfortunately that is a little bit beyond what my skills are going to do when it comes to computers. So we shall do our best to draw a very smooth curve on the right-hand side and on the left-hand side. So you can see that there are some similarities to that, y equals a over x squared, but it looks a little bit weirder. Okay, and that is because we have x plus 1 over x squared. So now we have our graph, okay? And it looks beautiful, and we should always be careful to y equals x plus 1 over x squared. Okay, label your graph, because what's going to come next is you're going to draw more things on top of it. So I see I was a little bit over-enthusiastic in terms of time and how much we'd fit in. So we shall see how far we get. You've got lots of work now. What we're going to use this for is to solve equations. So the first one, use your graph to solve the equation x plus 1 over x squared equals 1.5. And these ones are lovely questions, right? X plus 1 over x squared, that's our curve. So if we have here a curve, then on the other side of these equations, we have a line. So we would have y equals x plus 1 over x squared, and we'd have y equals 1.5. And an intersection between the two in a solution to the equation. So we need y equals x plus 1 over x squared. We've got that. Y equals 1.5. Well, we can draw that because that is a straight line. And it's a y equals, so it is a straight line that is horizontal. So we simply go to 1.5 with a ruler 1, 2, 3, 4, 5. And we're going to draw a line the whole way across our entire graph paper with a ruler, so it is beautifully straight. And we're going to label it y equals 1.5. Then we go on our graph and we look, okay, so where do they intersect? There's our intersection. So then we read down, and our answer in this case is here. So that's 1, 2, 3, 4, 5, 6, 7. So 0.7, and it's on the left, it's a minus 0.7. X equals minus 0.7. Now the thing to bear in mind, of course, your graph would look a little bit different to mine and a little bit different to the next person. So whenever you have a question like this, then there is leeway in the memo. They will accept a range of answers. So you don't have to freak out. You do have to be accurate and you have to be precise so that you do get within that range of answers. But the important thing is that you read the answer off your graph that you draw.